Let's talk about the next assignment. There's two parts to it. The first part of it is maintaining state of a React application using Redux. Okay. Up to this point, the state we have been managing the state using the out-of-the-box mechanism that React gives us. Right. We basically have some top-level or root-level container, right? That it maintains, that is a stateful component, and then that parent component then shares some of the properties with its children, or some of the state with its children, and then the children, down further stream, they might have some event handlers. You know, if you click here or drag or delete or update, they have to notify back their parent, right? That the state has changed. And you might have found it to be fairly cumbersome, yes, fairly inconvenient to have to communicate back and forth, between a container at the top and then all these children down below. You have to shuffle data back and forth. Oftentimes, this is referred to as property drilling. You have to drill the property all the way down to where you need it, right, and then notify event handlers all the way at the top of the chain of command, right? It's very, very cumbersome. Redux fixes a lot of this, right? Although it's very terse, sometimes very thick to understand the topic. We'll revisit it today, perhaps making it a little easy to understand. So yeah, we'll use Redux in a fairly simple use case. We're just going to use it for managing the state of the widgets. Right? We're going to be able to add widgets, update widgets, delete widgets, move widgets around, rename things, change their types and whatnot, all managed by the Redux. We're also going to make those changes semi-permanent by sending all these changes over to a server. Right? The server is going to be notified when these changes occur. Right? That we've added something, we've removed something. We're going to send it over to the server, and the server will maintain a server-side variables where it's going to maintain all these arrays of widgets and whatnot. Yes? Again, it will be permanent as long as the server is running. Right? If the server goes down, we'll lose all our changes. Right? To make it really permanent, we'll need to store it in a database, but that's in a later topic. Okay? Yeah. So we'll learn how to maintain state using Redux and persist our state through a RESTful web service. We'll need to obviously add Redux and React Redux to the project, the assignment that we've been working on, and this asks you to implement all the various artifacts that you need for maintaining state using Redux for the widgets. Right. So to implement the reducer inside of a widgets reducer.js, right? And here are the events that the actions, the various types of actions that the reducer should support. Being able to create a new widget, delete an existing widget, update an existing widget, find all widgets, or find a widget by its ID. Also, the actual rendering of the widget is going to be done in a widget list component. Yes.
For those actions, is that again for this assignment still on the JSON, or is that going to somewhere else?
It's still we're going to have an initial state, and that initial state will be provided by the server. The server will provide with a default set of widgets, right, with different types of widgets, and then we'll use Redux, right, to communicate back and forth to the server, getting an initial state from the server, right, and all modifications to the state will be notified to the server and synchronized with the server, right. There might be, depending on how you implement it, you might want to cache a lot of the changes in the Redux state. Okay, so you're modifying a state internally in the React application, and not until you click on save, then we send all the changes over to the server and make it permanent on the server. Right, that's one strategy. There's a couple other strategies. Some folks prefer to use a more chatty approach, and so every single change that is done to a widget is sent right away to the server and immediately stored. I'll leave it up to you how chatty your RESTful service is, or how much caching you want to do on the client side. Right? There's different strategies that we can use. So widget list component is the one who's actually going to render the widgets. provided a list of JSON objects that represent these widgets. The event handling and the plumbing of the state and to the properties of the widget list will be implemented through the widget list container. Right? This will be responsible for doing all the connect, right, and bringing out stuff from the state and mapping it to some property that the widget list component needs. So that's the responsibility of the widget list container. This is just some wireframes on what the widgets might look like. This is the widgets in the mode of being edited. Right? As a faculty, I can edit the widgets. Yes. So I can toggle whether I'm editing the widgets or I'm not editing the widgets by clicking on the preview checkbox over there. See the checkbox over there? If I toggle it and I turn on, if it's off, by default, all the widgets are in editing mode, right? And I can edit each widget. So for instance, here I'm editing a heading widget, right? Which I can put the text for the widget. I can say what size the heading is. I can give it a unique name, right? And here I can see the preview. Same thing with a list widget down below, right? This is a list widget that allows me to, has a text area. Notice that the form is a little bit different. The heading widget has an input field and a drop down. The list widget has a text area and a drop down. So different types of widgets, right, have different forms, right, because they have different attributes to edit, right? So a list widget, I can put items on an individual line, and then I can configure it on whether I want an unordered list or an ordered list, and then I can have a preview, and it sees that it renders either as bullets or as numerals. And there's a whole bunch of types of widgets. I can add new widgets by clicking the plus button here. I can rearrange the widgets by using the up and down arrow. Some students have gone so far as making these draggables, right, where you can grab it and then move it around, and which is pretty cool, but it's not required. But feel free to impress. There's a delete button. All the widgets have a delete button, right, which allows you to remove the widget. All widgets have a drop-down which you can change the type of the widget on the fly. Right? You can say, I want you to be a YouTube widget. I want you to be an image widget. I want you to be whatever widget. Right? And as you change this dynamically, the form changes. Right? Which basically is just hiding and showing different things. Right? Different components. Strategically, you show or hide driven by that drop-down. Yes? Okay, it's really one big widget. Right? But I only show certain input fields strategically, right, depending on what type of widget I select here. So notice I have heading here. I have the input fields that allow me to configure the heading widget. If I have lists, I have the input fields to edit the list widget. Yes? All right. There are different types of widgets that are listed down here. There's the heading widget, which we already looked at, right, that allows me to put the text and then choose the size of the widget. Just like I would type H1, H2, H3, yes? So it allows me to add one of those. There's the paragraph widget that allows me to add a paragraph, so I can type in a long paragraph, right? And it uses and adds a P, right? P for the paragraph. It has another one is a list widget that allows me to put different items in a different row. Right, and then it, for every item in a different row, it renders them as lists. Right, but I can configure them to be ordered or unordered. And there's another widget called the image widget that allows me to embed an image in my page that I can point to a URL, and it shows me what that image is. And there's one more, I believe. There's a link widget that allows me to add a link. Right, that I can point to some location, some URL, and the text that I want to embed in that link. This third URL, I'm not quite sure what it's for. Ignore it. I think that was typo. So these are all widgets. I can add a number of widgets. There's a plus sign at the top here, right? If you could say plus Right? I can say plus, and then I can add new widgets. I can add any number of widgets. Yes? It's very much what I can do in Blackboard, right? In Blackboard, these are all different widgets. Right? I can add a build content. I can add a new page. I can add a file. I can add an item, an image, a video. Yes? Right. Yes?
In the information in the assignment, it says to include a YouTube widget as one of the data types or widget types.
Yeah, no, that was part of the original assignment. I removed that. So, yeah, ignore YouTube. Yeah, I removed that. It used to be there. But yeah, so it's basically this on the right-hand side, right? Being able to add new widgets and move them around. Okay? Yes?
As widgets are currently associated with specific courses, and that's coming in the future
Yep.
assignment, as you mentioned, should we just always have the same, like a master list of widgets, pretty much?
Yeah, right now you're only manipulating one single list of widgets. Next week, we'll tie them up to the topic, right? Presumably, each topic has its own list of widgets, right? There's a one-to-many relationship between topics, has many widgets. This time around, we just have just one to simplify this, so you could actually do it in 1 week. It will be just one list, one widget list, okay? Okay, let's see, what else? So some students have, let me just revisit this preview and this save. All right, so preview, as I mentioned earlier, this toggles all the widgets, right? If it's an off, it shows all the widgets in their editing mode, okay? But if I click on the preview, it hides all the input fields, all the labels, and it only shows what that widget previews as, right? This allows a faculty to see what a student might see, okay? How the student is going to consume this content, yes? Right? So for instance, if I click here preview, and I have here a heading widget, and I have a list widget, it would turn into this. It would just turn into just a heading widget and the list, right? All the forms disappear, right? Because I'm not editing, I'm previewing it. Make sense? Right? All the labels disappear. The actual, I can see the actual content. So the toggle allows me to do that. Now, some students, usually half of the students, prefer to do the following. Okay? Some students prefer to, instead of using a preview button, what some students do is that they add like an edit button to each widget. Okay? And depending if I click on that edit button, it only shows the form, the editing form for that one widget. Okay? And then they toggle from an edit button, they change it into an OK button. Right? So that when you click on OK, it then updates the state of the widget, and it saves it, right? And then goes back to the preview. Okay? That's pretty cool. If you want to do that, go ahead. Right? That kind of removes or makes this preview button useless. So if you prefer to do the OK, the edit OK button, right? Then you don't need the preview button anymore, right? Because you're kind of always in the preview mode, right? And you only go into an edit on demand. Make sense? Also, the save button over here. This save button suggests that all the changes that I'm making are cached on the client, right? And not until I click on save will I then send it over to the server for permanent storage. Yes? Okay? And that's certainly a strategy. Right? Some students prefer to do the following. Along the same lines of adding an edit and an OK button here, what some students prefer doing is that when they click on OK, they notify the server immediately. Right? They don't wait for a save button. Yes? Right? If you prefer that strategy, then the save button is kind of useless. Right? I'll leave that up to you. Which strategy you prefer. Right? Obviously, one strategy is chattier than the other. Right? Sending lots of data many times over to the server. Some folks have gone to the extreme that every keystroke they're sending it over to the server and updating immediately. Yes, I think that's a little bit too much, but there are some arguments to that strategy. If you're the only one editing the course, you can it's okay for you to cache as much as you want on the client. Yes, since you're the only one editing the course. But if instead you have multiple authors working on the same content, then it makes sense to become very chatty, right? And update the state of the servers as quickly and as often as possible. Okay? So it's fine, whatever strategy you prefer, right? You can make the arguments for both cases. Yes? Let's see. All right, that's that. So that's the client side. That's React and Redux. On the server side, you need the client to send all this data across to the server, right? Notify the server, hey, here's a new widget, or this new widget they changed the title or the type change or whatever, right? We need to notify all these things to the server, and that's going to be done through a React service client, which you already have written right? You've written a core service. We're going to write a widget service. Okay, a widget service is going to be responsible for shuttling the data over to the server using HTTP AJAX calls to the server. And the server is going to expose certain web service endpoints, right, that's going to receive this data, and then it's going to save it into some local array of widgets. Yes? Right now, that list of widgets is going to start off as a static default list of widgets, yes, which changes over time as we send over several queries. But eventually, we'll tag along here a connection to a database where we can permanently save to this permanent storage. That's next week. Okay. So to implement that, we're asking you to create a Java class that is going to represent the data model that represents the data that we're storing. Right. So each widget is going to have a name, a unique identifier, the type from a enumerated data type, the order, so you can put it in different orders. Sort order, the text fields such as source, URL, and href, they all kind of mean the same thing, but it depends on whether it's an image, whether it's a link, right, whether it's a YouTube video. They all use different names for these properties, but they all mean the same thing, right? Some URL to some resource, right? Some URL to something on the network. Size, again, this is useful for the heading. Width and height, class, a CSS class that you could. These are options. We're not going to use them, but it's nice to have them. Style, value, data type. Okay. So that's the data model, right? That's going to represent the JSON object that's going to go back and forth between the server and the client. Yes.
I have several questions about multiple of the sections.
What's up?
So for size, width, and height, how are we supposed to determine that? Like, for example, images are often link stuff. So
Yeah.
would we need to have a function that checks what the
Yeah.
there is?
Yeah. No. So one of the things that are missing here, that used to be here, are fields for you to set the width and the height, right? That you can configure, which are no longer there. But that's where you would grab them. It would be provided by the client. The client would pass in whatever properties for width and height you would use, right? Which we're not. So for now, they're just going to be placeholder, and most of the time it'll be empty. Yep.
And for that won't be contained with that?
Included as part of the data model, right? With its own setters and getters, right? But nobody's not ever going to populate it.
Okay.
Yeah, we don't have a place to populate it from. I mean, you could go further and try to determine the size of the raw image and use that as a default. That'd be pretty cool. Yeah, but that's not required.
All right. For the size one for
Yeah, size is
which heading size it is?
yeah, heading is for this size here.
Okay, so it's
1, 2, 3. Yeah.
There's another section that I was wondering about. For CSS class and style, is that also going to be unpopulated?
Yeah, it's unpopulated. Yeah.
Okay.
But that it would allow, for instance, there's some fields that are common to all the widgets. So all widgets have, for instance, name. Right? They all have name. Right? That would populate the name attribute on a widget. Right? all widgets would have a name attribute.
Right. Yeah.
Yep. And just like ID populates the ID attribute, but CSS class would populate the class name attribute, and style would populate the style attribute. Yep. Yeah, so that's the data model. Next week, we're going to introduce this data model is going to become much more complex, right? Because we have courses that contain modules, modules contain lessons, lessons contains topics, topics contain widget, right? So we need to capture that relationship between multiple data models. So we'll do that next week. Then we have a service. The service typically is a class whose responsibility is to actually manipulate the data model, right? To create these objects, right? To add, to remove, to update, right? So this would be whose responsibility is to actually manipulate. In our case, our data model is just a list of widgets. Yes? The data model will become much more complex next week, right? But for now, it'll be just this list of widgets. Right? So it has CRUD operations to manipulate this list of widgets, such as create a new widget, retrieve from me all the widgets, or retrieve from me a widget with a particular ID. Update a particular widget with new data, right? Or remove a widget, an existing widget. Yes? Right. So this is to manipulate a data model, regardless from where it's being done, right? Whether this command is coming from the client, whether it's coming from within the server, doesn't matter, right? It's agnostic to where this command is coming from. In our case, the commands are coming from the client. Yes? Are coming from a React client. To do that, to connect the React client to the service, we use a widget controller, right? Which is going to expose that service, right? It's going to expose it to the web. Right? It's going to expose it to a URL set of a set of URLs, right? That are going to allow us to post to this URL. It's going to allow us to do a get, a put, and a delete. Okay? These are our HTTP methods, right? Our standard HTTP methods, and notice that the URLs follow a pattern. If you notice, they all start with API, they all end with widgets, okay, plural, and so it's based on a convention, the RESTful convention, that we use a noun, okay, as part of the URL of what is it that we are editing, or the type of data model that we're manipulating, right? And we use post to create. We use get for reading, for retrieving data. We use put to update, and we use delete for removal. Okay? Again, that's a convention, right? Very, very standard convention. Also notice that we are prepending all our URLs with /API. This is to distinguish HTTP requests to the server from static content like HTML or CSS, right? To distinguish that this is data that we're asking for. Yes?
Why are widget controller and widget service separated this time around? Since the first time we had just users and user.
Yeah, so it's usually it's best practice to separate the layer from where you're communicating, the communication layer, which is the controller. The controller is aware of HTTP requests, it's aware about JSON, is aware of a particular layer or data layer that it's communicating with, right? Whereas the service, its only responsibility is to manipulate the data, regardless of where the layer lives, right? Whether it's coming from HTTP or coming through some other network, or even from within the same business layer that might be using the service, all right? Okay. So it's a good practice to separate them. Our example is trivial enough that we might argue and say, well, why don't we make them the same, right? But nevertheless, it's best practice to separate them. Yep. We'll add another layer later on next week, which will be another communication layer of talking to a server, to a database server, right? And for that, we'll use JPA and data access objects. So our service will use that other layer, right? So the service will sit in between two layers, right? The network layer, right, and the database layer, or the data layer. It will, yeah. All these will be singletons, yes. Well, except the widget, yes. Also notice that some of these have a placeholder WID at the end, right? So some of these queries manipulate a particular instance, right, of an object. So again, as convention, the convention is that it starts with a noun, right? Noun ID for a primary key, right? So you refer to a particular instance. Here, since we're not specifying the ID in the get, since we're not specifying the ID, we mean that we want all of them, right? We want all the widgets. Give me all the widgets. Whereas this one is retrieve from me that one widget. Okay. Next week, we're gonna go a little bit further, and we could have several parent-child relationships between different objects. For instance, next week we'll talk about a widget belonging to a topic, right? For instance, you might say that topics, and then the ID of a topic ID, right? And so that's interpreted as telling me, retrieve for me all the widgets. I don't want all of them. I only want the widgets that belong to a particular topic. See that? Right. We'll talk about that next week, right? Being able to also use these URLs to establish relationships between the different data models, right? That a course contains modules, modules contains lessons, lessons contain topics, and topics contain widgets. So there's a whole bunch of one-to-many relationships between all these data models. Yes? All right, but we'll deal with that next week. So that's also part of the convention, right? These URLs, can capture, right, the relationships between the multiple data models. What else? Okay, so the service layer, so we're asking you to implement all these methods and the deliverables. So the deliverables will be that you'll have two repositories, right? You'll have the React work, or your React work, or the client and the component and the redux and all that. That will be done on your React repository, deployed to the React Heroku project. Yes. Whereas all the server and the RESTful and the controllers and whatnot, all that is going to be done on your Java GitHub repository, deployed on your Java Heroku server. Yes. Somehow they need to talk to one another. Okay. The client will be sending HTTP requests to the Java server. It'll have to go from one domain to another domain, right? So it'll be trying to break some security issues here, right? It's typically a browser stop, one JavaScript executing on some domain, trying to communicate with another resource in some other domain, right? It's cross-domain scripting. We don't allow that. So we'll see how to get around that with using a course and whatnot. All right, and we'll talk about that perhaps today. All right. Any questions? Yes.
On the assignment, when it says like this component should be in source/component/the component name, does it have to be exact, or can we put in more subdirectories?
Oh yeah. So that's just a suggestion that you should have at least that minimum organization. That components should go one place and containers in another. But yeah, if you want to break it up a little further, sure. Yes. Like for instance, widgets. Right, widgets. I'm saying here to use one widget component. A preferable way to do it is to break up each widget type in its own little component, right? And then have a parent widget component import all the 4 or 5 or 6 different widgets, right? And then you have logic to know which one to render depending on some value, the widget type would drive that.